Before we move on to more complex circuit problems, I wanted to give an example, this simple example. So this one says, this question is saying, which bulb is the brightest? I'm going to assume that all these bulbs, of course they are resistors, but I'm just going to assume that they are all the same bulbs, okay? So with the same resistance values. And using the concept we learned in the previous video, we can see that. So if we assume that this is 10 volts, then this one and this one will share 5 volts and 5 volts, right? And this one, if this is also 10 volts, then it's going to, so it doesn't really matter what the resistance values are. Because they are in series and they are the only resistances in the series circuit, they're going to have a 5 volts drop here and 5 volts drop there, so that they combine to give 10 volts. They make up 10 volts right there. In this case, I just drew this one a little bit differently from the previous video. So this is the same, equivalent to like this. So there's absolutely no difference between this circuit here and this circuit here. All right, because imagine like this one. So you can think of that point as sort of at this point right here. And even though this is bent, we can just straighten that out, and it's going to be the same as from there to there is the same as this from there to there. Okay, and then it splits and then comes back again over here. So that joint there will be the same as this one. So we know that this is going to have 10 volts drop there and 10 volts drop there. And obviously, the one with more voltage drop is brighter. So definitely these two bulbs, each, they are brighter than these two over here. Now let's have a look at this one. This is a bit more complicated, as you can see. But we don't really know what the equivalent resistance value for this one is. Okay, but so we can go through the complicated the mathematical calculation and figure out what the exact share of the voltage is for this one and these two. But if this is getting 1 volt, this will be getting 9 volt and 9 volt, right? If this is getting 2 volts, then this will be getting like 8 volts and 8 volts. And no matter what combination you choose, you're never going to get 10 volts for any of these. Unless, of course, you choose like 10 volt for that one, then you're going to be left with a 0 volt and 0 volt, which is impossible, because if certain current is going through this, some has to go through that as well, and you cannot get 0 volt there. 0 volt means no current is going through this. Okay? So doesn't matter what you do with these, it's going to be just this one will be the brightest. Okay, so this was actually a problem that was in I think it was a blue booklet in GAMSAT. So yeah, so to figure out exactly how much voltage is going through this, I think we kind of so we can assume that this is a 1 ohm, 1 ohm, 1 ohm, and you can choose 2 ohm, 2 ohm, 2 ohm, but the voltage drop across this one, this one, this one, they wouldn't change. Okay, so have a look at this. So we know that this is a 1 ohm. I mean, we can assume that it's 1 ohm, and if you combine these two from the previous video, we saw that this was equivalent to 1/2. And we saw the current going out of this was 10 over 6, 20 over 6. Therefore, that was 6.666. And therefore, this is identical to the previous question. So what's going to happen is we saw this. Yeah, we saw exactly the same case. So 6.6667 volts will be the drop over here. So this is going to consume 6.67 volts. And 3.33 is left. So this is going to be 3.33 amps and 3.33 volts there. And 3.33 volts there as well. So definitely this one here is brighter than that one there. but this is not brighter than this one. This is the brightest. So 10 volts is like the maximum you can get. So if you supply 10 volt from a battery, voltage drop of 10 volt would give the brightest color. So you can't have 11 volts. If the battery is supplying 10 volt, you cannot have like 11 volts. 10 volts is the maximum, therefore that would be the brightest. Okay, so that's the answer.